We're now going to look at predicting and balancing single displacement reactions. By way of example, we're going to look at the reaction of calcium solid with copper nitrate aqueous. So let's look at how that would look. Calcium solid is a metallic grey-black solid. Copper nitrate is an aqueous solution. You can always pick out what these are. The solids will always look like solids, and the aqueous solutions, or the AQs, will always look like these. Copper nitrate is a green solution, or green-blue solution. Calcium nitrate is a colorless solution, and copper solid looks like this. Alright, so what's happening here is that the calcium solid is turning into calcium nitrate. In other words, the calcium is being oxidized from calcium with a charge of 0 to calcium with a charge of 2+. You can look at oxidation as being an increase in charge. So calcium 0 going to calcium 2, that's oxidation. Now the copper nitrate is like copper 2+, and that's the aqueous solution, that's going to copper. So you can see that the charge is going down, or is being reduced. So we've got an oxidation here and we've got a reduction going on here. That's why this is called an oxidation reduction process, or a redox process. And you should always be aware that solids will always look like solids, and aqueous solutions will always be solutions in water. Solutions will always have the metal as a cation, and you'll always be able to tell that based on the AQ that's in the reaction. Alright, so let's take a closer look at the reaction process. The reaction process follows this kind of formula. So the calcium, which I'm calling A, becomes a calcium cation and becomes combined with the anion that was with the other metal part that was cationic. So the A becomes AC, and the BC in turn becomes B. So the calcium became calcium nitrate, the copper nitrate became copper solid. Alright, so how can we predict whether these reactions are going to occur? Well, we can predict whether a reaction will occur based on what's called the activity series. And this activity series is based on standard reduction potentials and the amount of voltage given out by certain reactions. And it turns out that the way this works is that any element will react with any cation that happens to be below it on the activity series. And the reverse is true as well. If a cation is above the metal on the reactivity series, then the reaction will not occur. So let me show you an example of this. If we've got the reaction we're talking about where we've got calcium and copper nitrate gives calcium nitrate and copper. The metal here is calcium, and that's what we're looking for on this chart. So there's the calcium there. The cation is going to be copper 2+. So we can see where copper is on the activity series, and it's right down here. Now, since the calcium is higher than the copper 2+ on the activity series, we know that this reaction will occur and will proceed. And the reasoning behind that is that the reduction potentials, or the voltages, will be positive and will allow for this reaction to occur. Let's say we reverse the reaction now. We start out with copper solid and we try and react it with calcium nitrate. So we look for copper here, and then we look for calcium on the activity series, and we see that Ca will be up here. So you can see that the cation is actually above the metal on the activity series. So the metal is easy to identify, it's always the solid, and the cation is always easy to identify because it always has AQ next to it. So as long as the metal is above the cation on the activity series, the reaction will proceed. But if the cation is above the metal on the activity series, as it is here, this would be Ca and the Ca2+, and it's above the copper, then the reaction will not proceed. Alright, so let's look at a couple of examples of that. So let's say we've got this question here. We want to figure out whether or not this reaction will occur. So we're looking for the element. The element is always a solid, so the answer there would be sodium, and you would say that it is more active than Pb2+, or sorry, Pb4+, which is going to be the cation here. Nitrate's a pretty easy one because nitrate is always negatively charged, so 4 of those would be -4, which would make the lead 4+. So sodium is more active than lead, so the reaction will proceed. So just looking at the activity series, you see sodium is above where the Pb4+ would be, so we know that reaction will proceed. Alright, let's say we've got copper and Pb4+. So we've got copper and Pb4+. We'll look up here. We see copper is actually below Pb4+ on the activity series. So that means that since copper is less active than the Pb4+, the reaction will not proceed. Alright, so that's the basics of all of that. The other thing I would like to point out is that if we know that a reaction will not proceed going in this direction, for example, we know copper won't react with calcium nitrate, what we can be sure of is that the reverse reaction will proceed. So we know that copper nitrate plus calcium will react to give copper and calcium nitrate. So saying that there's no reaction doesn't give us any information. It does. It does tell us that the reverse reaction would actually work.